I would like to work for you the problem 10 from the last SmartWork homework. I understand many of you had issues completing this particular question. And I think perhaps the first problem you had was in the part where it said to take the structure and rotate it. You notice here there's a methyl and an H and a deuterium, and over here there's a deuterium and an R and an R. And so the first thing they wanted you to do is replace the two R's with the H and the methyl. So if I were to rotate this so that the deuterium is in the downmost position, the methyl would come up in the group position before me, towards me, and the hydrogen would move to the position behind me. Of course, in order to be a methyl, we need more hydrogens. And that's the first part of the problem. Second, of course, we have to put our lone pairs in, 2 for the NH2 minus, 3 for the chloride. We need to put in our formal charge on the NH2 minus. And then we need to put in our curved arrows, starting from a pair of electrons on the NH2 going towards the deuterium, which is lined up anti to the leaving group chlorine. And just to make it nice and neat, I'm going to drag the arrow so I'm not crossing over anything. Second, I need to move the pair of electrons that was part of the C deuterium bond and make it into a CC pi bond. And again, I'm going to drag it down to make it pretty. And finally, I need to show the leaving group leaving, taking its pair of electrons with it. And that should give me credit for this box. We'll see. Okay, so then in order to draw the product of this E2 elimination, you got to realize that this methyl and this hydrogen are 60 degrees away from each other. And as the two leaving groups leave and this thing flattens out into a pi bond, the methyl and the H are going to be cis to each other. So there's my pi bond. There's my groups on both ends. And on one end, we have a methyl and an H that are cis to each other. Okay, so that's my methyl and H. And on the other side, we have a hydrogen and phenyl that are 60 degrees from each other, and when they flatten out, they're going to be cis to each other. On the same side as the H and phenyl are going to be next to each other. So where the methyl is, there's also an H. And where the hydrogen is, there's also a phenyl. And there's my alkene answer. Again, with the phenyl and the H cis to each other. You can see they're both pointing backwards 60 degrees apart before the alkene gets formed. And the methyl and the H are going to also be cis to each other.